Hi, this is Juan from JuanTutors.com. Welcome to my totally free office hours. Today we are working on the August 2016 New York Algebra 1 Common Core Regents, problem number 31. If you want to access these exams anywhere in the world, you don't have to be from New York. Go to nysedregents.org. Click on the appropriate tabs and all the exams are freely available to you. So here's the problem. Find the zeros of f of x equals x minus 3 squared minus 49 algebraically. So there's a couple of things I need to point out. First of all, this concept of algebraically. You and I may disagree about what algebraically means, and you and the test makers may disagree on what algebraically means. But here's a big point. The quadratic formula is numerical solution, okay? So if you get it completely right, it's not algebraic. Okay? So if you get it completely right, you do get a point. Why do you get a point? This is the second thing I need to point out. On these exams, if you look at the rules for part 2, answer all 8 questions for this part. Each correct answer will receive 2 credits. Clearly indicate the necessary steps, including appropriate formulas, substitutions, diagrams, graphs, charts, etc. I'm reading fast. Utilize the information provided each question to determine. Note the diagrams are not necessarily known to scale. And then this part, this beautiful part that's relevant to us right now. For all questions in this part, a correct numerical answer with no work shown will receive only 1 credit. Now, of course, you don't want only 1 credit. You want 2 credits, but you don't want 0 credits. So you should know that if you don't know how to do 6 problems like this across part 2, 3, or 4, but you know how to get the correct answer on this beautiful thing called a TI-84 or whatever version of a calculator you have, you should definitely use that product to get the correct answer. So you'll get a point. So let's say we type it into our calculator, x minus 3 squared minus 49. I wonder what the zeros are. So you do need to know that the zeros are the x values. Oops, I'm using my eraser. The x values for which y equals 0. So that's what we're looking for. They're also called the roots, okay? Roots. So we can scroll and look, we're actually already at x equals 10. So if you write on your test 10, and also the other root, so you scroll down, you're like, what is the other root? Oh, the numbers are increasing like crazy. No, it's the other way around. Let's go up. They're going negative, and now, oh, there it is, -4. If you write this on your test, you get a point. There it is. It's free for you. 1 point. Even if you don't know how to do this question, remember that there's a lot of ways to solve problems. Some of them get full credit, some don't, but this is a point. And remember, you know, it's horrible to think about it this way, but you know, tests are a game of points, and you want the maximum number of points no matter what. And it's a Regents. It's on your permanent record. You know, these things. It matters what the highest score possible that you get is. So you definitely want to eke out the most points you can. That's a correct answer for a point right there. Okay. And then colleges will love you just a tiny bit more. Worth it. So what's the first? Let's call this method 0. Because it doesn't give you a full credit, but it gives you something. But with method 1. And we're going to go for algebraic method now. And we're going to solve it by the inverse operation method. So solve by the inverse operation. Okay, method, sorry. And so what is the inverse operation method? The inverse operation method is the method that we use when the variable appears only once. So they want the zeros, meaning the roots. X minus 3 squared minus 49 equals 0, right? Okay, let me just make sure this is recording. I made a mistake. I'm not editing that out, but I actually did this whole video, didn't realize I was not recording. So I just wanted to check. So this is what we need to do. We need to solve this equation algebraically. We notice that x only appears once, so we can use the inverse operation method. We invert all the operations one at a time. The first operations that's performed on x is a subtraction of 3, then the squaring operation, then a subtraction of 49. That's the last operation done. That's the first operation we undo, plus 49 with the inverse operation. Okay, and this method works whether the numbers end up being nice, meaning integers, positive, negative, even for algebra 2 people, if they end up being imaginary, this will work. Radicals, they will work. Okay, so the last operation performed on x now is the squaring operation. That's the first operation we undo with the inverse operation, which is the square root operation. So x minus 3 equals, now you do need the square root, the square roots of 49, because remember we are unperforming an operation. For every positive number, there are 2 square roots of that number, the positive square root and the negative square root, and we do have to consider both, because if we're undoing an operation, there's nothing to tell us whether the square root of 49 was the positive 7 or the negative 7, and in fact it does give us 2 perfectly valid solutions, so we do have to do that. Plus 3, okay, and then x equals 3 plus or minus 7. And for the Regents, that's actually enough. They accept that as the answer. But equals, for teachers who, for those of you who don't have teachers who accept that as an answer, so 3 plus 7 or 3 minus 7. A common error is to put the plus or minus in front of the 3 when it's already in front of the 7. It's on the 7, okay? So equals 10, or 3 minus 7 is negative 4. And that is a perfectly valid answer. Okay, so those are 2 answers to x, and we could check our answer. One of the best things that students do is check their answer every time. So x minus 3 squared minus 49 equals 0, and we check x equals 10, and we do 10 minus 3 squared minus 49 equals 0. 10 minus 3 is 7 squared minus 49 equals 0, so 49 minus 49 equals 0. Okay, and 49 minus 49 is in fact 0. So that's a valid answer. I highly recommend you check your answer every time, because if there's no point in doing all that work and then getting the wrong answer without knowing that you got it wrong. X equals negative 4. Okay, we got negative 4 minus 3 squared minus 49 equals 0. Negative 4 minus 3 is negative 7. Squared minus 49 equals 0. And in fact, the second check is faster than the first, because you get here, negative 7 squared is already, we already know that negative 7 squared is 49. So 49 minus 49 from the previous problem equals 0. So 0 equals 0. And this is correct. So the answer is correct. So this is a perfectly valid answer. They don't require you to check your answer. That's not an absolutely required thing. It's something that I require of you, because you want to get the highest grade possible. So let's do another problem. We're going to do it in a slightly varied method. We're not going to do a quadratic formula, because that is not an algebraic method. This is a problem that we created on our own. Find all the roots of g of x equals x plus 5 squared minus 324 algebraically. So how do we do this problem? We're going to do this in a moment, but I recommend that you pause the video, try this on your own, and if you get the right answer, if you get the same answer as we do, definitely hit the like button. Subscribe, because it does help you, and let your friends know that we're here to help them as well. If you're a teacher, please do feel free to show these to your students online during class. You could show them to, you could ask your students to watch them at home, whatever you want. These videos are truly freely available to you to use however you wish. So here's the problem. X plus 5 squared minus 324 equals 0 algebraically. So what we're going to do is we're going to expand it. So method 2 is expand and factor. Now the expand and factor method is a little bit longer in this example, but I want to show you how to use it. So x plus 5 squared minus 324 equals 0. Okay, so what do we do here? We expand this. We get x plus 5 times x plus 5 minus 324 equals 0. Okay, I use the FOIL or each with each method to multiply these out. X gets multiplied by each of the x and the 5 on this side, and then the 5 gets multiplied by each of the terms here. X times x, so the first, outer, inner, last. Okay, x plus 5 times x times x is x squared, plus x times 5 is 5x, x times 5 is 5x, and 5 times 5 is 25, minus 324 equals 0. Okay, and then x combined like terms, x squared, 5x, and 5x is 10x, and 25 minus 324, you could use your calculator to do this. 25 minus 324 is 299. Correct. Negative 299. Negative 299 equals 0. Okay. So we use what I like to use is what's called the factor rainbow. I call it the factor rainbow. A lot of kids call it the factor rainbow. You need two numbers whose sum is b, and also the same two numbers whose product is c. Okay, so what we use is the factor rainbow, and the factor rainbow, the benefit of the factor rainbow is that the number of factors that these integer, that the number of ways to add to 10 is infinite, even with the integers, but the number of factors, integer factors of negative 299 or of c is finite. So we start off with the factors. So 1 is always a factor of c, with its factor pair being c, 299. Okay, or positive, the positive version. So then we go through factors and see if they're factors or not. We go through numbers and see if they're factors or not. 2 is not a factor because this is not an even number. 3 is not a factor because 2 plus 9 is 20, which is not divisible by 3. 4 is not a factor because this is not even. 5 is not a factor because this does not end into 0 or 5. 6 is not a factor because 2 and 3 are not factors. 7, let's test 7. So 299 divided by 7. 7 is not a factor because the factor pair is not an integer. 8 is not a factor because 2 is not a factor. 9 is not a factor because 2 plus 9 is 20, which is not divisible by 9. 10 is not a factor because 2 and 5 are not factors. 11, let's test 11. 299 divided by 11. I know this is a long process, or it feels like a long process, but it actually is short. It shortens the process very quickly. So 11 is not a factor because 27.18 is not an integer. 12 is not a factor because 2 is not a factor. 13. So 299 divided by 13. In fact, 13 is a factor, and its factor pair is 23. So 13, we connect it with 23. Now, we can keep going. 14, not a factor because 2 and 7 are not factors. 15, etc., all the way to 23. So the reason this process is faster, because if you keep increasing the factor pair, 14, 15, 16, 17, 18, 19, 20, 21, 22, and then 23. 23 is already on the list of factors with a factor pair. So we can stop because no new factors can be found, because every large factor comes with a small factor pair, and every small factor comes with a large factor pair. So we're done. But there is a reason why we could stop at 13 and 23. 13 and 23 are both prime. So this is actually the prime factorization of 299. And once the factors are two prime factors, that's it. That's the largest, that's the factor pairing. It's either 1 and 299 or the two primes, 13 and 23. So we test numbers to see if any of these add up to 10. So remember, one of them has to be positive, one of them has to be negative, because the product is negative 299. So let's test 1 and 299. 1 plus negative 299 is not 10. Negative 1 plus positive 299 is 298, not 10. Negative 13 plus 23 is, negative 13 plus 23 is 10. So there it is. Negative 13 and 23. And negative 13 times 23 is negative 299. So those are the factor pairs. And how do we use those? We can factor this now as x with minus 13 and x with plus 23, because the x 23 is positive. And then we use the zero product property, which says this: if p times q equals 0, then p equals 0 or q equals 0. And there is no other product property really for any other numbers other than positives and negatives. You could determine the sign of a number based on the sign of the factors, but not the actual values. Zero product property is special because now we know that one of these factors is 0. So x minus 13 equals 0, which we add 13 to both sides, and we get x equals 13. And that's one of the answers. Or x plus 23 equals 0. So we subtract 23. And we find that x equals negative 23. And we could check our answer the same way we did before by plugging into the original equation, 13 plus 5 squared minus 324. Check if that's 0. Or we can also do it the same way we did the other one. Let's deactivate equation 1. And then we go to equation 2. y2, and we do let's see, x plus 5 squared minus 324 324, and then we go to the table, second table, and we scroll, and one of them happens to no, I lied. So we scroll and we look for the zeros. There we go. Negative 23 is one of the zeros right there. So we've checked our answer on our calculator, and that is a correct answer. And then we scroll to the other one. 13 is a factor. 13 is a solution. So we scroll down to 13, and we better get 0 as y2. 12, 13. There it is. So this is, in fact, a correct answer. So now we've not only done this problem in 2 different ways, but we've also given you a way to get the answer and get a point out of this if you forget how to do this, or if there's similar problems that you forget how to do, use your calculator. Don't forget that it's a wonderful tool. And if you get the answers in that way, they'll give you a point. But now we also have 2 different algebraic methods, which is phenomenal. Now we have 2 tools that can be used in multiple situations. Sometimes one way is better than the other, and then there's no way. It really depends on the problem and also on you, which one's better than which. Okay, so yeah, definitely thanks for watching. I definitely appreciate you. You can do it. You just keep working at it. Keep watching these videos. Keep doing your homework. Keep doing what you do in school. Thanks for watching, and stay tuned for the next video starting right now.